Hi guys, it's Mrs. Smith here. We're going to look at our first lesson. I hope everybody's doing well. Happy Tuesday if you're watching this on Tuesday, but some of you will be watching it on Wednesday. So happy halfway through the weekday to those people watching it on Wednesday. So we are going on with the first kind of section here of our distance learning, and we're looking at probability and odds. Okay, so the first thing that we're going to be doing is you're going to be filling in these definitions that you can see that I've already filled out for you in your chart. So what I want you to do, so you should have your notes up to one side, and then they're the notes that I'm going to go through with you guys up here as well. And you can have your screen split so that you can write them down. I want you to take a minute and copy all of the notes here and all the definitions, and then we'll kind of go through them together. So pause your video right now and just take a minute and copy down your definitions. Okay, so hopefully you have all your definitions copied down here. So just to kind of go through them, possible outcomes is just basically all of the possible outcomes that you could have. Okay, sample space is a list of all of those possible outcomes. Probability is the likelihood that an event is to occur. Favorable outcomes are the events that you want to occur. And then unfavorable outcomes are the events that you do not want to occur. Okay, odds are basically the comparison of favorable to unfavorable. And then we have theoretical probability. That is basically what is supposed to happen. So if you were to do an experiment, like what should happen. So for example, if we were flipping a coin, we should land on heads 50% of the time. Okay, so the ratio of favorable outcomes to total possible outcomes. Okay, what should happen? Experimental probability is if I actually gave you a coin and told you to flip it 10 times, not all of you would necessarily get heads 5 times and tails 5 times. Okay, so some of you might get 3 heads and 7 tails, or 6 heads and 4 tails. Okay, and if you have extra time and you want to try that, you can try flipping a coin 10 times and seeing what the probability is, your experimental probability that you get all heads. Okay, so those are the definitions that we have here. And if we look down at probability, okay, we already said it's the likelihood that an event is to occur. So when we're trying to find the probability, we want what we want to occur over the total possible outcomes. Okay, so probability is a number from 0 to 1. Okay, you can write that as a fraction. It can be written as a decimal, or it can be written as a percent. Okay, so if you're comparing probability, if the probability is 0, that means there's no chance of it occurring. Okay, if the probability of something is 1, that means there's a 100% chance that it's going to occur. So comparing probability to benchmarks such as 0, 1/2, and 1 can help us understand how likely an event is to occur. Okay, so 0 is impossible. Okay, 1 is it's certain to happen. Okay, so the fact that, or the likelihood that there's always going to be a Monday, a happy Monday, would be 1, right? So each week we're always going to have Monday. Okay, 100%. So that would be a 1. And then something that would be equally likely, right, is a half. Impossible would be 0. So if we look at this first example, it says a bag holds 8 pieces of paper numbered 1 to 8. Okay, so first we're going to kind of write out our sample space. So all the possible outcomes would be 1 through 8 here. Okay, so each paper has a number on it, 1 to 8. Nick chooses a piece of paper at random. What is the probability that Nick will choose a 4? Okay, so if these are my possible outcomes, there's only 1 4 out of 8 total possible. Okay, so the probability of a 4 would be what we want to occur. So we want a 4 over the total possible outcomes. Okay, so there's 1 4 That's what we want to occur. There's only one thing that we want to occur over 8 total possible outcomes. So the probability of picking a 4 is 1/8. If we look up at our chart here, okay, 1/8 is smaller than a half, right? So if it's smaller than a half, it's going to be unlikely that this is going to occur. And if you notice how this was written, this is also notation here for how to write probability. So it's whatever you want the probability of. So P parentheses 4, they're asking for the probability of picking a 4. Okay, so that's what the notation would look like there. All right, so going down here, it says a number cubed with the numbers 1 to 6 is rolled. What is the theoretical probability of rolling a 3? Okay, so again, we're going to list all of our possible outcomes. So if we roll a number cube, we have these 6 possible outcomes. Theoretically means what should happen. Okay, so theoretically, there is a 1 out of 6 chance that we roll a 3. Right? So we want to roll a 3 and then over the total possible. So there's 1 3 out of 6 possible numbers that we could roll. Okay, so the probability that I roll a 3 is 1 out of 6. Again, if you look at your chart up here, that would be unlikely. Okay, so it's below a half, so it would be unlikely that that would occur. All right, so for B, what is the theoretical probability of rolling an even number? How likely is this to occur? So again, if we list out all of our possible numbers, and then we look at our even numbers. So we have 2, 4, and 6. Okay, so we want an even number over the total possible numbers. So we have 3 even numbers out of 6 possible numbers, which would give us a 1/2 chance of happening. Okay, so we know that 1/2, again, if we look up at our chart here on the number line, is equally likely. All right, so again, probability is always what you want to happen over the total. Okay, so now we're going to move on to odds. So odds in favor of an event is what you want to occur over what you don't want. Okay, so it's not over the total anymore, it's over what you don't want. Okay, so the total does not go on the bottom. And that's always the mistake people make. So for odds, they'll still put the want over the total, but then they're actually finding probability and not the odds. Okay. If it says odds against, you really need to be careful. If it says odds in favor, it's the want over don't want. If it says odds against, this is now basically switched. Okay, so it's what you don't want over what you want. Okay, also sometimes they might just say, what are the odds? If they just say, what are the odds, they actually want the odds in favor. Okay, if they want the odds against, it will always say odds against. So if we look at this first example, suppose you randomly choose one letter from A through J. Okay, find the odds in favor of choosing a vowel. So the first thing I'm going to do is write out A through J here so we know what letters we have. Okay, and we want the odds in favor of choosing a vowel. So if we look at our vowels, we have 1, 2, 3 vowels. Okay, so the odds in favor, remember, is what we want to occur, and then it's not over the total, it's over what we don't want to occur. So there's 3 vowels, and there's 1, 2, 3, 4, 5, 6, 7 that are not vowels. Okay, so again, don't count up the total. That would give you 3 over 10. That would be the probability of choosing a vowel. We want the odds in favor. Okay, so now we're going to do the odds against choosing a C. So we're basically going to switch this. So now it's what we don't want over what we want. Okay, so if we want choosing a C, then don't want would be everything that's not a C. So there's 10 letters here, okay? So there's 9 that are not a C, okay? So what we don't want is something that's not a C. So there's 9 that are not a C, and what we want is a C, okay? So there's only 1 that is a C. Okay, also for odds, a lot of times you're not going to see it written as a fraction like this. You're going to see it written as a ratio, like 3 to 7 or 9 to 1. Sometimes people get confused with odds against. So if you're feeling like you're confused with odds against, but you understand odds in favor, the other way that you could do odds against is you could actually just do odds in favor and get like 1 to 9, and then you just flip it. Okay, so if it's odds against, you just flip that answer and get 9 to 1. All right, so C here says find the odds in favor of choosing a consonant, not a vowel. Okay, so again, is what we want and what we don't want. Okay, so a consonant is not a vowel, right? So it's anything that's not a vowel. So from up top here, we knew that there were 3 vowels. That means that there's 7, because we know there's a total of 10 up here, that are consonants. Okay, so they're not a vowel, which means that there are 3 that are vowels, which are not a consonant. Okay, so this would be 7 to 3. All right, so that's odds. Again, remember it's the 1 over the don't want, not the 1 over the total. And then if it's odds against, you just flip it to make it the don't want over the 1. All right, so the last thing that we're going to look at is theoretical versus experimental probability. So theoretical, again, like we explained, is what should occur. Okay, experimental is what actually happens if you do the experiment. So in this example, it says a number cube with the numbers 1 to 6 is tossed 30 times. The results are recorded in the table. Okay, what is the experimental probability of tossing a 3? How does this compare to the theoretical probability? So first of all, they want the actual experimental probability. So we're going to use this table here. So somebody tossed a number cube 30 times, and these are the results that they got. Okay, so we're looking for the probability that they tossed a 3. So we're going to circle everywhere where we see a 3. Okay, we know they tossed it 30 times. Okay, so out of 30, they got 6 threes. So they got 6 out of 33, which means that's 1 over 5 if we simplify it. Okay, so what's the what's the experimental probability that they got a 3? It's 20%. Okay, so they got a 3 20% of the time. If we look at theoretical probability, that's actually what's supposed to happen if we were to toss it, and like what actually should happen. Okay, so we're not actually doing the experiment. So theoretically, if there's 1 3 and we're tossing it 30 times, that means that, okay, so I just actually wrote out the possible outcomes on the side, right? So if we tossed it 30 times evenly, we should get 5 threes out of 30. Okay, so that would be 1/6 of the time. So we should get a 3 1/6 of the time. This is about 17%. Okay, but when we actually did the experiment, we got a 3 20% of the time. Okay, so it says how does this compare to the theoretical? The experimental probability is greater than the theoretical here. Okay, so what you need to do now is make sure you have all these notes. If you have any questions, maybe star them for our live session.